create or destroying mass or energy, what can we do with it? I think we wrote this, and I wasn't sure how to spell it. It can only be transferred, right? You can only transfer mass or energy from one thing to another, okay? So it's important to understand that whatever energy, this is the theory. What is the theory of how the universe started? What's the scientific theory? The Big Bang, okay? So the theory is all mass and energy has been created at that moment, and it's never changed since. So the mass of the universe, and the energy content of the universe hasn't changed since then, which was like 5 billion years ago, okay? So the concept there is everything is just being transferred. Let's think of one example of how energy is transferred. Happens every single day. It's why life exists.
Energy from the sun.
Yes. What does the sun give energy to? Max. Plants. How do plants use it? Photosynthesis. And that creates what? Sugar, energy for the plants and sugar, and then the plants grow, and then what happens? Think of the chain of events. So from the sun to the plants, from the plants, animal eats the plants. Could be us, could be other animals. Then we either eat those animals or we just eat the plants. So we get the energy from them. And then how do we use our energy? You're using it right now, I'm using it right now. Breathing, talking, walking, learning, thinking, that's all needs energy. Okay, building things, creating things, playing sports, instruments, singing, whatever, dancing, doing whatever you do. Okay, so just think of there's always a transfer of energy. Thanks. There's always a transfer of energy going on. Hold out your hand, please. Good luck by the time I get done with this. Interactive chemical. Oh, you get a big one. You can drink it if you want. Pat, help me out here. Speed it up a little bit. Hand this out to your people. All right. We're having fun with ice today. Well, Marcy doesn't want her ice, but those are on the floor here.
Are you going to keep one for yourself? Are you
Man, this ice is ice cold. All right, now, here's what you're going to do. Put it in your hand that you don't write with. Sorry about that. Wipe it off. It's just water. Write down in your notes how I am teaching you conservation of energy using an ice cube in your hand. Go. And I want you to hold the ice cube for a little while. Don't say it, write it. Explain how I am teaching you conservation of energy using the ice cube.
Do you have like, oh my god.
I want you to feel the sensation when you write. That's why I'm not having you get rid of it.
It's wet.
Doesn't have to be a super long explanation, okay? Explain how I'm teaching you about conservation of energy by holding an ice cube. And if it gets to be too much for you, you can get out and put it in the sink. Somewhere back there.
I can't feel my hand anymore, so it's kind of,
Actually, I have a better idea. You keep writing. I'll just get a big beaker. You can tell me. Okay.
Yeah, that's what I'm trying to do. It keeps leaking out.
I get mine to shake.
Early, get your book wet, man. A little bit of torture in the morning.
Water and someone.
All right. Now, sorry that you got some wetness issues here. Just wipe it on your pants or something. All right. Just water. Now, we're on Slade. All right. Now, I want you to finish what you're writing, okay? While you're doing that, I'm going to show you something else. Actually, you know what? Okay. All I want you to do is when I go around, I want you to touch it. Don't squeeze it. Just touch it. Just feel the temperature. It might be super cold. It might be super hot. Don't burn yourself.
That's the heat solution. It says it.
It's not hot. Just touch it. Don't squeeze it.
Hey, what's
Okay.
our
Just want you to feel what happens after I initiate the magic.
in the graphic stuff?
Okay, here we go. Ready? Watch. I'm gonna get this in the thing here. So now I'm gonna bend this little thing in here. Watch what happens. Science. Now feel it. Okay, now what you're going to do is you are going to write down how, stay with me, listen. Now I want you to write down, when you touch this, how I am teaching you the law of conservation of energy. So you got two different scenarios here. Two different scenarios, okay? So I want you to write down, you already did the ice cube thing. Now you got this hot pack, right? It's a hot pack. Explain how you're supposed to learn or how I'm supposed to teach conservation of energy using these two examples. Holding an ice cube is one example. Touching a hot pack is another. I want you to write it down. And I wanted you to touch it first just so you could understand that it wasn't hot first. Okay, just so you had a frame of reference. And it's still getting hotter. But you know what? I do have to tell you that this was a physical change. It's not a chemical reaction in here. Most hot packs are chemical. The ones you buy in the store that twist, break, blah, blah, blah. Most of them are chemical, but you can have some that are physical. If I have time at the end, I'll explain what happened here. But we're just trying to focus on the energy part right now. The heat, the energy. So it was not a chemical change. It's a physical change. And I'll prove it to you. I'm going to reverse this today, later, and then tomorrow you'll see it's back to the way it was. So that's good indication of a physical change. You can reverse that, right? Chemical changes are very hard to reverse. So anyways, you're writing how the ice cube, holding an ice cube shows conservation of energy, and how touching or holding a hot pack shows conservation of energy. I'll say holding, but touching a hot pack. So, conservation of energy, what's going on here? And after we talk about these two, what we'll do is kind of define what heat is. Now, usually, as you can tell, I kind of like it when you guys get together and talk about things, but today, just for the sake of time, I'll just go over it. Basically, there's one of two things kids think. When you hold the ice cube, some students think that the cold from the ice cube goes into the hand, and some students think the warmth from the hand goes into the ice cube. Well, which one is correct? There's an easy way to remember this. Cold does not exist. There's no such thing as cold. There's only such thing as heat and energy. So when things feel cold to us, or we feel cold, what does that really mean? There's a lack of heat. So no one goes around talking that way, though. You don't walk outside and go, man, there's a lack of heat today. It's weird, okay? No one, people look at you like you're strange. So say the word cold in real life, that's fine. But in here, let's avoid using the word cold. Let's say what it really means, that we're lacking heat. So with that concept, holding an ice cube, the transfer of energy is shown, or is not shown, we should say felt, by, what is it? What's the correct way? Is the cold going into the hand, or is the warmth from the hand going in, the energy from the hand going into the ice cube? Well, what's happening to the ice cube? Melting. The only way you can melt something is by giving it energy to break the forces of attraction. Because solid particles are like this and just kind of vibrating. If you give them enough energy, they vibrate enough, they kind of break free of each other and start moving around. So you have to give it energy to melt. The transfer of energy is felt by the heat from your hand is going into the ice cube and melting it. Hot to cold. Energy always moves hot to cold. Every time, all the time. It can't do anything else because cold doesn't exist. It's always hot to cold, or warmer to colder, or higher temperature to lower temperature. We're going to start talking about temperature tomorrow. Okay? So from your hand into the ice cube. But what about when you hold a hot pack? The energy is transferred. Again, transfer. That's conservation of energy. It's not disappearing. Your energy isn't leaving your hand and just vanishing. It's going somewhere. Okay, that's the ice cube. Here, the energy is transferred from what? From the hot pack to your hand. Okay? It's always hot to cold. That's the last thing I want to write. I'm running out of room here. Energy and heat. Energy always moves from higher temp to lower temp. Always. Always, always, always. If you were to touch the side of the leg of your chair or your desk, it would feel cold to us. Why? The energy is going from your hand into your desk leg of the desk. Okay? That would be easier than holding an ice cube, but the ice cube is more dramatic. So hopefully you remember this, because these are good examples of how energy moves. And this is all you need to know for your quiz and for conservation of energy. That's really all you need to know, because this covers a lot of understanding right there. Okay? So no homework. We're all done. Bell's going to ring real soon.